Namaste, you are listening to Apna Gurukul Maths. We are discussing number system, chapter number 1, class 9th NCERT. We have discussed so far the operation of with square root of real numbers, operation on real numbers, and all the other topics are done. We are left with now laws of exponents of real numbers. So now, before that, are you clear with law of exponents for rational numbers? If not, we will go through it very quickly after a while so that we do not find it difficult to understand law of exponents for real numbers. I hope you are very much clear with operations with exponents. How do we operate with exponents? How do we use the laws of exponents? We'll have a quick revision for that also, and then we will go through the laws of exponents for real numbers. Let's begin. So before that, very beautiful quotation. Maths is like a gym for our brain, as gym helps us to build our physical muscles. Math help us to develop our mental muscles, because developing our mental muscles is as important as developing our physical muscles. But most of the time we forget to exercise our mental muscles. So let's do some maths to exercise our mental maths. Let's begin. So law of exponents for rational number, let's go through it quickly. So the first law of I have written it as first law because this was the different law which we studied in class 8, right? So a to the power 0 is always 1. Now this is in mathematics, it's called as an axiom. Now in mathematics, axiom means a statement or a formulae or any equation like this, which does not have any proof, but this is accepted universally in the area of mathematics. Everywhere you go, this is accepted. That is why it is called as an axiom. So a to the power 0 is 1. That means whatever number you have, if you raise it to the power of 0, it's 1. There's a very good understanding to this also. What is the meaning of power? If I tell you 2 square, what is the meaning? 2 times 2, right? We are multiplying 2 times. That's why 2 square is 2 times 2. 2 times 3 is 2 to the power 3 is nothing but 2 is multiplied 3 times. That means 2 times 2 times 2. What is the meaning of that if I tell you 2 to the power 0? Multiply 2 0 times. So that looks meaningless, but yes, it has got a meaning, which is 1. The second law which we discussed was a to the power minus m equals 1 by a to the power m. Suppose you have an integer, negative integer in the power. If you want to change this to positive, just reciprocate it. I would rather say you will get it a positive integer. Then we saw that if we have the base same but the powers are different, and when we are multiplying, what do? We keep the base same, add the powers, right? We will take a few examples for that, so that becomes much more clear for you. Then a to the power n m, this is m actually, a to the power m divided by a to the power n. Conditions is the same, the base is the same, powers are different, but now we are dividing. So this time instead of addition we subtract, so we get m minus n. Yeah. Now let's suppose we have a to the power m multiplied by b to the power m. What do you observe over here? The powers are the same, but the base are different. So we just multiply the bases, as here we have multiplication, and the power is carried forward. Similarly, if we have division, we just divide the bases and the power is carried forward. Now the special thing over here we have to remember is where a, m and n all are natural numbers. I repeat, all these laws, a, m, and n were natural numbers. That is why it is called as law of exponents for rational numbers. Now, let's recall how do we operate on this 17 square times 17 to the power 5. So as you can see, the base is the same. So 17 to the power 2 plus 5, because we add the power, so this becomes 17 to the power of 5. Sorry, what am I writing? It's 17 to the power 7. Yep. So now you can expand it, but it's not really required because we are not testing your calculation. Nobody is testing your calculation in such ways concepts. You are being tested on your concept. Okay. Now here we have 10 to the power 2 to the whole power 5. So what is the property? A to the power nm. So 10 to the power 2 times 5. So that gets us to 10 to the power of 10. Yep. Now over here we have 3 to the power 10 divided by 3 to the power 7. Base is the same, but power is different. We are following division. So what happens? 3 to the power 10 minus 7. We get 3 to the power 3. So 3 3s are 9, 3s are 27. We can write very simply. Now again, here we have a negative integer, right? So what can you do? You can also follow the this similar to this a to the power m multiplied by a to the power n. I will tell you both ways how to do it. So if we just simply a to the power m plus n, if you do it, the answer will remain the same no matter what process you do. So we get 3 to the power minus 1. So 3 to the power minus 1 can be written as 1 by 3, which is the second identity discussed today, right? Or what is the process? We will first change this 3 to the power 9 as 1 by 3 to the power 9, because minus 9, when you take the reciprocal, the exponents become positive. That is what it was. A to the power m minus m becomes it's equal to 1 by a to the power m. So 1 by 3 to the power 9 multiplied by 3 to the power 8. Wait, I wrote 38. 3 to the power of 8. So now once again, what can I do? Since 9 is smaller, so I'll bring it down. So it becomes 1 by 3 to the power 9 is bigger, I mean 3 to the power 9 minus 8. So I get 1 by 3, and 1 by 3 is the answer. Over here, as you can see, now we discussed that exponents in these rules a, m, and n, all the powers as well as the base are natural numbers. But as you can see here, we are getting the power as a rational number. What do we do in such situation? A power as a fraction. So the rules exactly remains the same. Okay, now we will finally write the rules later, but let's try to understand how do we solve it. The base is the same, so we'll keep the base same. Then 2 by 3 plus 1 by 3. So when you add it, what do you get? 2 to the power 2 plus 1 is 3 by 3, that is 1. So you get the answer is 2 to the power 1, which is nothing but 2. That's all. Very, very simple, right? So this is the same rule we extended for real numbers. But before that, we need to understand one very, very important thing. Now, what is the real meaning of 4 to the power 3 by 2? What does this mean? So now we give this with a formula which is called as, if you have a to the power m by n, what is the meaning of that? Either you take square root of n, and inside the bracket, inside the square root we have a to the power m, or it's the other way around. Now why does that? So we will try to understand that very, very carefully. So please focus. So now 4 to the power 3 by 2, when it is written 4 to the power 3 by 2, can I also write it as 4 to the power 3 to the power 1 by 2? Yeah. What property have I used? I have used the property that if you have a to the power m times n, yeah, you can also write it as a to the power m to the whole power n. Yes or no? That is what I have written. I will write it once again here. If you have a to the power mn, I can write it as a to the power m multiplied by n. Yes, over here we are dealing with fractions. In the till exponent till rational numbers, we were only dealing with natural numbers. That's the only difference. So now, what is square root of any number? Means 1 by 2 of any number to the power 1 by 2. It is nothing but square root. So it becomes square root, or you need not write 2 for square root. It becomes 4 to the power 3. Does that make sense, my dear friends? Or how can we write it further? So let's evaluate it. 4 fours are 16, 16 fours are 64. So this answer is coming out to be 8. Or the same problem can be also written as 4 to the power 1 by 2 to the power 3. Yes or no? What is the meaning of that is square root of 4 to the whole cube, because 1 by 2 can be written as square root of 4. So square root of 4 is nothing but 2 to the power 3. We are getting the same answer. That means we can do it both ways, and that is why it is written over here. So what the order of operation does not matter here. So, but we do not introduce the commutative property here. This is just how we understand this, right? So what is the conclusion? A to the power m by n can be written as square root of n in under the square root a to the power m, or it can also be written as square root of nth root of, I'm sorry, I have been telling square root. I'm so sorry. This is not square root. This is nth root. Okay, now shall I explain you that also? Okay, I'll explain you that in a while. So this is nth root of a to the power m, and then over here nth root of a to the whole power m. This is the formula which we have to take. So now why did I told nth root? I just missed it completely. I'm so sorry for that. Okay, so let's suppose I have a to the power. No, I'll take numbers to make it easier for you to understand. Suppose I take a to the power 1 by 2. So this is nothing but square root of a. Suppose you have 8 to the power 1 by 3. This is written as cube root of 8, right? That is how you write cube root. If it has to be 8 to the power 1 by 4, that is written as fourth root of 8. If it has to be written as 1 by 5, then what is the meaning of that? It is fifth root of 8. If it is to be written as 1 by 6, it is nothing but sixth root of 8. And similarly, we get to, if it is 1 by n, we write it as nth root of 8. I hope that makes a lot of sense. And that is why we write a nth root here. Yeah. Now that is how we reach to the exponents, law of exponents for real numbers. So over here, the rules remains exactly same. Only thing is over here, a is greater than 0 is a rational number. So we are only, real numbers. We are only dealing with positive real numbers, and p and q are rational number. Now the p and q, the powers are obviously rational number. We do not deal with the power as irrationals for now, right? So now let's solve a few questions based on what we have discussed. Okay, so 32 to the power 1 by 5. How will we solve this now? My dear friend, please focus carefully. Okay, so now how can you write 32? 32, can I write it as 2 to the power 5? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That means if I'm multiplying 5 2's, I'm getting 32. So that's why I can write 2 to the power 5 to the whole power 1 by 5. Yes or no? Now, what does the rule says? That 5 and 1 by 5 can be multiplied. So 5 times 1 by 5, 5 and 5 gets cancelled. I get the value as 2. I hope that is very much clear for you. Now, in the second problem, you can do one more thing. You can pause the video. You can try all these problems. I hope all the problems are visible. You can try all these problems at one go and then come back and you can verify your answers. That will be a very good way. As we started the class, but as we have already discussed, math is more about doing by yourself. Yeah. So now 32 to the power 6 times to the whole power 1 by 5. So how it becomes 32 to the power 6 by 5. Yes or no? That becomes 32 to the power 5 can be written as 2 to the power 5, and this becomes, well, I'll skip one step, this becomes 6 by 5. It's already 6 by 5. So 5 and 5 gets cancelled, so we get the answer as 2 to the power 6. How did they get cancelled? As you can see, 5 times 6 by 5 was there, right? So 5 is in numerator, 5 is in denominator, so I can obviously cancel that. I have written denominator as 1 because 5 can be written as 5 by 1. So I am left with 6, so that is why it is written as 2 to the power 6. Yep. Similarly, 125 to the power 1 by 3. So how can I write? Try to observe. Over here in the denominator, I have 3. So can I write 125 in some way so that the power is 3? Obviously, we can. So 5 to the power 3 to the whole power 1 by 3. Yes. So again, using the law a to the power mn equals a to the power mn, m multiplied by n. So this becomes 3 times 1 by 3. 3 gets cancelled, 5 to the power 1. So now you might be observing whatever question we are doing, the denominator of the fraction is getting eliminated. So that is most of the problems which we'll discuss for now is of that kind. Okay, because that is easier and for our level that is enough for now. Right. So now moving on to a little bit more difficult problem than whatever were doing over here. 2 is the common base. So 2 to the power 2 by 3 plus 1 by 3. We have already discussed this, I guess so. So 2 to the power 3 by 3 and you get 2 to the power 1 because 3 and 3 gets cancelled. So we get 1, 2 to the power 1 is the answer. Now moving on to the next question, 512. Over here, as you can see, 3 by 9. Can I reduce? Let it be 3 by 9. Can I write 512 as something to the power 9? This is one of the easiest thing you can. So You can write 2 to the power 9. Let's try to verify. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16 times 2 32, 32 times 2 is 64, 64 times 2 is 128, 128 times 2 is 256, 256 times 2 is 512. 5 plus 4, 9. So there are 9 powers to 2. You get it as 512 to the whole power 3 by 9. Once again, the same rule. So you get 2 to the power 9 times 3 by 9. 9 and 9 gets cancelled. So you get 2 to the power 3, that is equals to 8. I hope that makes sense. And that's easier, of course, as well. Now, 3 little difficult questions. I won't say a lot difficult, but a little bit difficult. Yeah. I'll change the ink and let's progress. Now 64, in the same manner as we did, it can be written as 2 to the power 6 and once again to the power 5 by 6 multiplied by 1 by 8, or also 1 by 8 can be written as, I hope you can understand, it can be written as 2 to the power 3. Since we have to make the bases same and the powers we have to operate on, we are trying to do this. So 2 to the power 6 times 5 by 6. So 6 and 6 gets cancelled, multiplied by 1 by 2 to the power 3. So I get 2 to the power 5 multiplied by 1 by 2 to the power 3. Now they are in division, obviously. So when you proceed further, it can be written as 2 to the power 5 divided by 2 to the power 3. As you can see, it becomes the normal laws. So 2 is in the base and the powers are different. So what do we do? And it's obviously division. 5 minus 3. So the answer becomes 2 to the power 5 minus 3 is 2, and that's how you get it as 4. I hope that makes sense. If not, just you can mention that in comment where you got confused, or you can just go back to the video, listen to the problem once again. You will be able to understand it. If still not, you can comment down. We can I can make one more video to explain this. That's not a big deal. Okay, so now similarly 81. Can I write 81 in some way or the other so such that the power is 4? Obviously I can. 3 to the power 4 is 81. So 3 to 4 times 6 by 4. So 4 and 4 gets cancelled. And obviously we have 3 divided by 3 to the power 6. So what am I left with? 3 to the power 6 divided by 3 to the power 6. And obviously, as we know, when we are dividing and if we are dividing the same numbers, we get the answer as 1. Okay. Now, this one is really interesting question. Now, inside the bracket, you can observe the powers are the same, but the base are different. So what is the law says? 16 times 9 to the power 1 by 5 to the whole power 25 by 10. Yeah, we will not try to reduce it for now. Let's get going however the question leads us to. So 16 times 9 is 144. And then you can observe 1 by 5 times 25 by 10. Yes, so 5 times 5 and then 5 ones and 5 twos are. So you get 144 to the power 1 by 2. So this is 144 to the power 1 by 2 is nothing but root 144, which is nothing but 12 is the answer. And that's how the answer for this one is 12. Yeah, I have been using only the laws of exponents. So what did I do? I first saw the powers are the same, base different. So I multiplied the power bases, that's what the rule says, and the power remains the same. And as we saw, powers can be multiplied, so I multiplied, I simplified that further. I got 1 by 2 as the answer. So 144 to the power 1 by 2. So square root of 144 gives me 12 as the answer. And that is all for this particular chapter, number system, chapter number 1, class 9th NCERT. Now, there is one more special, beautiful thing about this number system. I will be discussing, that will be an extra video that is not a part of the syllabus. I'll discuss that still. And then as promised in the introduction video, we will be having a very amazing problem solving technique, problem solving video with a wonderful problem solving technique. So that helps you to do any kind of problem very, very effectively. See you in the next video. Until then, keep smiling. Jai Hind.